Welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video, we will hopefully finish our implementation of our KD tree. In the last video, we took it to the point where we have the median. We used what's a fairly efficient algorithm for finding that. It looks something like a quicksort. And now we need to actually make our node and set the values in it. So we've set the split dim and the split value. The main thing is we need a left and a right, as well as a points. And if we're going to do this recursively with our make tree, this would work something like this. So this code was held over from the quad tree. Make tree of something again. Okay. Now we could call these make trees on the appropriate parts of PS. So we can take PS and then take value and then drop the appropriate number of elements. The problem is, if we have an array, one of the advantages of the way we've done this is that everything that we're doing is on the appropriate parts of the array. And so it's actually more efficient if we go ahead and call this passing in our start and end values as well. And then when we come down here, what we pass through is not start, or not 0 and ps.length, but start and end. And when we call make tree, we can pass, here we go from start to let's do actually, okay, our find median did make an assumption in there. I'm going to have to do one other thing here. Start plus end over 2. We'll come back to that. Start, let's actually define that as mid. Because I'm going to need it in 3 places. One is there. The other, this is going to go to mid, and this one is going to go mid to end. And I think the way I'm doing this, I want that to be distinctly less than, so that equal values go on the high side. Now the only problem is that our find median needs an additional argument. That additional argument is passed all the way through, and it is used here instead of ps.length. So it is the index that we're actually looking for. The advantage of doing it this way is that the entire thing happens inside of a single array. Now it's supposed to be pnts.size. Okay. So that goes through, and now we have finished the code for making the tree. Now all we have to do is the visiting the neighbors. So I'm going to uncomment the code that we had for our quad tree and talk about how this is going to change. So first off, how do we know if we are on an empty node, or sorry, on a leaf? Well, one way is that left is null. Okay, so if the left pointer is null, we know that we've hit a leaf, and then we just need to run through all the points and check the distance. Same basically the base case that we had for our quad tree, The only difference is the exact nature of the condition. In the quad tree, then, we had 4 other cases for recursive calls that we could make. In this case, we only need 2 recursive cases, and that is whether the point that we're looking for is plus the search distance overlaps with our given region. So let's go back. Let's look at what our KD tree looks like. So if I'm searching around this point right here, I have a certain region around it. All I care about is whether that region overlaps with the cut. If it goes on the left side, then I have to search the left child, or the low side. If it goes on the high side, then I have to search the right child as well. So I want to take, and this is not always P and T sub 0, so the code that I just took out had checks for P and T sub 0 and P and T sub 1. Here, the only thing that I care about is the split dimension for this node. And what I want to compare that to, so if that, and I'm going to do this left first, so if that minus whatever is less than n dot split val, then I recurse on n's left. And we can copy that code, and if the point's value in the dimension we split on plus the search distance is greater than or equal to the split val, then I recurse on the right. So it is possible that I will recurse on both the left and the right if the search area overlaps with it. If it only overlaps with one, I'll only go down to one side. Just to give this a quick test, I have to admit that if there are any bugs here, they will wind up going into a different video. So instead of quad, we'll call this KD. And our KD tree needs an extra argument of how many dimensions. Okay, and we run this, and all of our tests pass. So now let's be honest, this is a very, very simple test, especially for the KD tree right here, because our max points is 3 and I'm never adding more than 3 points. I could take it down to 1, which would make this test actually a little bit stronger for it. And then, okay, we do have an error. The error is there. Array index out of bounds in the find median. Okay, so I will look at this code and we will come back for one more video where we go through and we fix what's happening in the KD tree.